Welcome, class. This is activity 114, spinning with spirographs. What are we going to do in this lesson? We're going to create an abstract drawing similar to a spirograph drawing and using it with loops and iteration. Okay, so more loops, while loops, and iterating. Cool. Examine the effects of infinite loops and zero iteration conditions and predict how many times a while loop will iterate. So sometimes while loops keep repeating forever, and that's intentional. And sometimes you want it to repeat or until something happens an unknown amount of times. And experiment with the effects of operator precedence in code execution. So a reminder, we have our list of commands that is slowly loading up here. So I haven't been building this since the other lessons. Okay, slow. It's got to wake up too. But we're going to be starting right here on 114 things. And as we get new commands, I'm going to post them in here. So there's also this resources, Python turtle methods. Its methods are it's probably the same stuff that I have there in my list. But let's see if they have some things that we don't know. Oh, okay. So there's a few things I'm seeing in here. Dot S draws a circular dot with diameter S. Okay, I'm going to add that in there. Wow, this is just taking way too long. It's being super slow. Oh. Okay, well that can wake up. I'm going to come back to that later. No, I kind of want to do it right now, but wow, it's lagging. Okay, I'll come back to that later. Zero iteration conditions and infinite loops. In the last activity, you modified loops, mostly using the less than and the modulo or modulus operators to achieve different effects. Yeah, we had this, is the count less than like 5, and you start at 0 and you count it up, right? We were just using less than. Sometimes we use modulo to like check just it was like so rotating between even and odds and stuff like that. So that's all we did. In this activity, you will gain more comfort with loops and learn how to troubleshoot situations in which loops don't seem to be behaving as you expect. Yeah, because we can do way more stuff with while loops. Either your loop never starts or never stops. You'll also be using math operators in the order of operations to modify behavior in code. Oops, gotta know order of operations. This will give you more flexibility when you attempt to solve problems or create unique effects. Yeah. So sometimes you might make a while loop, and you got to be careful on how you write it to make sure it behaves how you expect it to. Like if you don't do the conditional of the while loop, the thing at the top, like right here, if you don't do that correctly, like you do a greater than when it should have been a less than, it's not going to behave the way you expect. Let's see if this thing caught up yet. Dot. Yes, it did. So I'm going to add things. Draw a circular dot. So draw a dot. Wow. Dot with diameter S. That's just not working. I'm actually going to pause. Okay, we're recording again. So I've added the dot command. Draws a dot with diameter S. Other things I found were hide turtle. Makes the turtle invisible. So I'm going to add hide turtle to this. So, oh, that's useful because before, sometimes when you draw something, you don't want to see the turtle cursor at the end. And in the past, I just moved it off the screen, but that may be easier to do. Okay, so pen down, pen up, set heading, shape. Sets the turtle shape to S. So I think I put that in there earlier because I saw it before. Yeah, I did it up there. Changes what the turtle looks like. So I'm going to keep it. Show turtle. Yeah, I guess I should have show turtle if I hide turtle. So. And then. Okay, speed. Okay, I used speed before, but didn't know how it works. Set the turtle speed to an integer value S in the range 0 to 10. That's good to know. Speed goes 0 to 10. I think 0 is the fastest. I think 0 is the fastest, and 10 is slowest. So, and then I'll say number must be integer between 0 and 10. Okay, there we go. It's lagging a little bit when I type things, but that's okay. But I got everything on this list, so cool. It's always good to add every command I haven't used. All right, actually onto the lesson. Read the comments below and then run the program to see if it behaves like you would expect. So, okay, so we're going to read the comments as we do this too. So, painter's turtle, speed 0, lift up the pen, go to this, set the cursor to square, and set the color to salmon. That's a new color in there. I'm going to add to my list of colors. I kind of was writing down every color I see. So, oh, I saw someone did beige last time, and salmon's now a color. Okay. All right. Oh, and the shape we can do a square. So I'm going to actually write that down in here. So how we can do shapes, you can do square, circle, turtle. Actually, a turtle shape. That's what I know so far. I'm sure I can find a list somewhere online. Okay, line 5. The value of the line starts at 5. Okay, while line is less than 5, while the value of the line is less than 5, it never is. Do all these things. Well, yeah. And then that's it. One thing you might notice, so if I run this, I think it's just going to do nothing. Yeah. So you start at 5, but while less than 5, well, it's never less than 5, so it never does the stuff in here. So I think that's what you're supposed to see. So, right, and before we did the count, we'd have the count start at 0, right? And then we'd have to go up, and then we have this thing that would increase the count. So, and, you know, it should loop 5 times. But if you start at 5, then it's not going to work. Okay, so nothing in here is going to run in this code. So the code you just examined included a 0. Explain the example in your own words. I would say since the variable line starts at 5 and the while loop conditional asks for line is less than 5, the while loop will never iterate. So I'll say iterate. It's never going to run. If I say run, that will never, because line is already too big. So I might say it like that. You can say it in your own words, though. Modify the code so it draws 5 circles. Well, how do we do this? Got to start at 0. And then let's go. This is the line you need to change. Boom, boom, boom. You see those? Salmon colored circles. All right, run the program now and note your observations below. Okay, so there, we fixed it. Now, so that's the thing. You got to watch where you start. Now, run this program. And let's see what it does. Okay, it keeps repeating. So if I'm watching this close, it starts out with, looks like salmon circles, and then like a bluish color circles, but it just keeps rotating forever. That looks neat. It's kind of like LEDs lighting up. So what's going on in this code? So what do I say? Hey, it keeps drawing. I'll do capital letters. It keeps drawing circles in a big circle. Starts, it switches between 2 colors, maybe? Yeah, I'll say that kind of stuff. Notice that. So it just keeps drawing it, and it never stops. Cool. Don't wait for it. It'll never end. I'm just going to stop. Here's another example. So, okay, why does this happen? I don't know if this is, I haven't seen this lesson. Maybe it goes through. Well, why is it repeating forever? Let's look at this code. Notice we start with line equals 6, and it says, while the line is greater than 5, and then it seems like this is where it does stuff. And then this makes line, add 1 to it, so the next one's going to be 7. It says, if line modulus 8 is equal to 0, change the color to navy. And if line modulus 36 equals 0, change the color to salmon. I know we haven't done if statements yet, and this is Project Lead the Way if you're listening. It's kind of annoying that you throw if statements out, but you don't teach it until later in this lesson, in this unit. I hate that. But for my class, I'll explain what an if works. So it's similar to while where it has conditionals. We say if this thing is true, then you do what's inside. But you don't keep looping like you do in while loops. Like ifs is just you check it once. And if it's not true, you move on. Okay, so it's kind of a simpler version of while. Like while will just keep looping. If just runs once. So if this is true, modulo 18 is 0, switch to navy. Modulo 36 is 0, switch it to salmon. So what does this work like? So basically, I think what happens, every 18, you switch the color to navy. So it starts off as salmon up here. And then 18 in, it's going to switch color to 18 in, it's going to switch the color to navy, right? And then at 36 in, so another 18 in, it'll switch the color to salmon. So every 18 circles, I think if I run this, yeah, I bet if I count this looks like 18 circles. Okay, there's some weird behavior that like this works, but it's kind of gross. So like when you take a line and modulate, okay, this is kind of advanced, but I kind of want to explain this. So when you do line, modulo is 36 and equals 0. So like, what if line equals 36 right now, right? So I'm going to throw this up. Oh, I can't. Oh, I'm going to throw this up on the screen right here. I'll move it down so you can see this. If we had line, what if line equaled 36 right now? Well, if you did that and you went 36 modulo 18, that's going to go, how many times is 30? So how do you get, that's actually going to be 0 because 36 divided by 18 is 2, remainder 0. But 36 modulo 36 is also 0. So you got, oh, you can't see that. It's also 0. So you have this weird thing every 36. And I wanted to say this because what's going on is at 36, what it does is this one is going to be true and it changes it to navy, but then this one's also true and it changes it to salmon right after. So it does both. What's a weird thing is if I move this right here, watch what happens. This is going to be navy forever because whenever this is true, this is always true. So this becomes true, but then right after it changes it back to navy. So that's kind of a weird observation, but I just want to throw it out there because I don't know. I don't know. Maybe they play with it later in the code. Here's an example. No, I haven't run this yet. I'm doing this live with you, so that's why. Here's an example of an infinite loop. Okay, let's run it. Okay, it's looping forever. Also, why is the code above considered an infinite loop? So line equals 4 and line, while 4 is less than 5, it does all this. And then it says line equals line minus 1. So it starts at 4 and it goes to 3 and 2 and 1, 0, -1, and so on. Why is this considered an infinite loop? I would say because the while loop will repeat forever. There's no way if the line keeps going down that this will always be true. It's like we asked this question about, it's the unsolvable algorithm. How many cigarettes do I need to smoke to cure lung cancer? Like, it doesn't work that way. So in this problem, if you subtract 1 every time from 4, you're always going to be less than 5. It's like, how many dollars do I need to lose to make to have more money? I don't know. Doesn't work that way. So yeah, so it starts at 4 and decreases by 1. It's never going to achieve 5 or greater. So that's why it goes on forever. Okay, compare and contrast zero iteration conditions with infinite loops. So zero iteration is like the one at the start where it didn't run at all because this was 5 instead of 0. Infinite loops just keep repeating forever. So you really don't want to make a while loop that doesn't run at all. I mean, you don't want to run that. Like, you don't make that on purpose. Unless it should run in some conditions. That seems weird. It's like a tree falling in the woods. Does it make a sound? I don't know. Create your own program that includes a zero iteration loop and an infinite loop. Why would I make a zero iteration loop? As you program your own turtle behavior, you may find the reference turtle Python. Okay. Include a turtle maneuver that would occur if the iteration were non-zero. Okay, so I'm going to make one up. So I'm going to go subs equals 5. While I'm going to say subs, and what time of subs are we talking about? You all know. Say it right now. You know it. Subs is greater than, while subs, I'm going to say equal $6. Print, hey, that's, I got to do the parentheses. Hey, that's what the meal special of the day costs at John Smith Subs. Okay, so when subs is equal to 6, and if I run this, it ain't going to do anything. It's just done. So subs is 5, and while subs is equal to 6, I do this. But subs is never equal to 6. It's always going to be 5. Right? So it'll just repeat forever. And now I go, while subs is less than 6, an infinite loop would be less than 6. Print, that is not enough money for the daily sub special. Yeah, you have to have at least $6. So what happens when I run this? See what happens when I run this. It will keep repeating this forever. Telling you don't have enough money. You only have $5. Now, I can make it. Now, what if, okay, so that's how it works. This repeats forever because I'm not changing subs. And this one will never run at all because subs equals 5. So there's my examples of infinite loops. Now, their examples include things like printing out a sub. You go subs equals subs minus 1. Sure, if you want to put that stuff in there too, you can. I don't care. But you don't even need to have those like changing the subs. Ooh, my computer just slowed down. Did not like that infinite loop. School computers, man. Similar types of looping situations can be done with repeat until style loops as well. In repeat until a condition iteration, an infinite loop occurs when the ending condition will never evaluate to true. So, okay. I almost want to put like vocabulary words down too. I should do that as a list of vocabulary. But, okay, never mind. I'm thinking of myself. Similar types of looping situations can be done with repeat until style loops. Repeat until style loops as well. That's a weird thing. With repeat until style loops. So I would say this is repeat until is the style of the loop. That is a weird sentence right there. Repeat until style loops. I feel they need repeat until style. They need a hyphen between these. And this is like in quote. The repeat until style loops. They need something else in there. A hyphen right there. And this is like in quotes, but then that looks really gross. Or this should be all caps, repeat until, like how it is here. In repeat until condition, an infinite loop occurs while the ending condition will never evaluate to 2. In repeat until condition iteration, if a conditional evaluates to true initially, then the loop body is not executed at all due to condition. So sometimes you have an infinite loop in a way, but it's not really infinite. It'll just keep looping until something changes, right? Uh-huh. Uh-huh. Hold on. All right, so it repeats until something changes, okay? We'll come back to that later. That was confusing me. I think the way they word this is really weird. But the idea with loops is that maybe we don't loop like 5 times in while loops. Like that's what we did last time. We just looped a certain number of times. And what we're going to learn now in loops is that, okay, maybe I have loops keep looping forever or never loop at all. But the amount of times that something loops might be based off of it's not always the same amount. Maybe it's based off some user input, okay? So maybe the user says how many times they want to loop, or it'll keep looping until the user does something, all right? So I would say this, like loops, while loops don't just always do the same amount every time. It depends how you make these. So we'll show you some more examples. Arithmetic operators, the order of operations. So, okay, if you know how to use PEMDAS, you can skip this part. But PEMDAS, or order of operations, let's go back to elementary, middle school. PEMDAS, I hope you know what this means. Math in Python works the same way as math should be in the real world, following the rules of PEMDAS. Parentheses, exponents, multiplication, division are together, and add and subtract are together, right? The order of operations. So if I had this problem right here, 6 times 10 divided by 5 times 2. Multiplies and divides are at the same level, so you just go across. 6 times 10 is 60. 60 divided by 5 is 12, and 12 times 2 is 24. So you go straight across. All right? Now, remember, add and subtract. Yeah, you know order operations. One thing you might not know is the mod operator is in the same boat as multiply and divide. Okay? So that's good to know. So if you can add modulus, the mod operator, to this, and just it follows the same pattern. So 6 times 10 is 60. 60 divided by 5 is 12. 12 modulo 3 is going to be 0. And because there's 0 remainder, it goes in 4 times. And 0 times 2 is 0. So you can just throw mod in there. Python has some operators of its own, such as the dot operator. So that's actually an operator, painter.write. And it's considered after parentheses and before any mathematical operators. All right. So, but you really wouldn't use this to do math. It's not a mathematical operator. It's just an operator that indicates like this is the method called write inside of this object painter. All right. Don't worry too much if you don't understand that. Don't need to know for now. But those aren't mathematical operators. Mod is a mathematical operator. All right. Examine the 2 programs below. Each use arithmetic operators in the same number to move the turtle right. Where is it? Uh-oh, I'm going to pause. All right, we're recording again, so had to refresh. Examine the 2 programs below. Each uses arithmetic operators in the same numbers to move the turtle object. Arithmetic or arithmetic? Arithmetic, arithmetic. I think both, you can say both the same ways. I remember having this argument somewhere. Arithmetic, I think it's arithmetic. Arithmetic. But I think they're spelled the same way. I think arithmetic is the adjectives. Arithmetic is the noun. Huh. But spelled the same way, like read and read. Weird. Okay, moving on. So, examine these. Hey, look, I get a new color. Turquoise. Turquoise. Just add it to the colors list. Okay, where's my colors? There's a new one. Jesus, going so slow. Okay, so we got this big old math equation. Really? What's this going to do? It's going to go forward a certain amount. And then this one's going to go forward a certain amount. Okay, what's this math equation here? I don't know. These are going to come out to different numbers. And you know what this is going to be right here? I don't know. Okay. You can do the math at home. 18 divided by 4. Oh, really? Oh. Actually, this is weird. So, okay, I'm gonna do it on here. Okay, we're gonna open up the whiteboard again. So, Python is doing this weird thing. So I want to actually do this with you. So I'm gonna write down the math right here. Come on, pen. So it's 4 minus 5 plus 7 times parentheses 2 minus 18 divided by 4 times 2, right? I guess we don't need that extra parenthesis in there, so I can erase that. Oh man, everything's lagging. Okay, so order of operations here. We have to do things inside the parentheses first. 18, oh, it's divided by 4. What's 18 divided by 4? So 16 divided by 4 is 4. That's actually going to be 4.5. So now what we have is 2 minus 4.5 times 2 times, okay, 7. And this 4 minus 5 in parentheses is going to be negative 1. You can do that. You can combine this thing right here, and we combine these right here. Okay, this is in parentheses, right? Oops, I guess I got to move this up. So this will be negative 2.5 times 2, because this part, and then times 7 right here, and this will be plus negative 1. All right, so multiplying all this together, you get 7, let's go, 7 times negative 2.5 is going to be negative 14, and it's going to be negative 17.5 times 2. And if you did that, that's going to be negative 35 plus negative 1, negative 36. I think that's negative 36. Now, that other number, oh man, I have to write, the other sequence looked like this. 4 minus 5 plus 7 times 2 minus 18. Yeah, if you don't like PEMDAS stuff, you can skip ahead. Just forward the video. Divided by 4. Oh, jeez, this just looks awful. Oh. My computer doesn't even want to run. Too many things open. 4 minus 5 plus 7 times 2 minus 18 divided by 4, parenthesis, parenthesis, times 2. Okay. 2 minus 18 is going to be, this thing right here is going to be negative 16 divided by 4. I keep doing that with the 2's. And this will be, okay, 5 minus plus 7 is going to be 12. So it's going to be 4 minus 12. So these parentheses cancel out to 16. That parenthesis and that parenthesis are right there. This one there, and this is times 2. 16 divided, negative 16 divided by 4, that's going to be, for this one right here, negative 4. Yeah. Oh, order of operations, so fun. Times 2. And then we can do everything in parentheses again. Oh, multiply first. So it's going to be positive 48. 4 times 2. And then, I have to get this up. And then what you're going to get is going to be negative 44 times 2, which is negative 88. So completely different number. Now, I did all this math, and we're going to come back to this later. This decimal right here, this doesn't actually come out to this. This is a spoiler for a future. So when you do 18 divided by 4 in Python, in their integers, this is actually going to be 4. They chop off the decimal. Because remember, integers don't have decimals. It doesn't actually work that way. But that's for a future lesson. Okay, I went off topic a lot right here. I'm going to probably pause this video soon. We'll do a part 2. Let's see. Use your knowledge of math operators to write the following algorithm. Ask the user to enter 2 numbers. Determine if the first number is evenly divisible by the second number. Recall that not equal compares the inequality. Repeat steps A and B until the numbers are evenly divisible. Okay, get 2 numbers from the user. So this will be my pause after this. Whew. Okay, so let's go. First number, we're going to call this x equals integer input. Give me your first number. Okay, and then y equals integer input. Give me your, I'll just use, give me your second number, please. Okay, so got the 2 numbers, right? Boom. And if you want to test these, or hit play. It's always worth testing. First number 4, 2. Got it. Done. Works. Loop while the numbers are not divisible. The remainder is 0. So that's your hint. Okay, so you can use modulus, right? While, okay, the numbers are not divisible. X divided by y. No, not divisible, that's modulo. So we can go x mod y does not equal 0. So while that does not equal 0, and you don't need parentheses around modulos. I can do it this way. While that does not equal 0, that means they're not divisible. I want to say, hey, determine whether they're easily, and go, I'll say print, hey, those aren't divisible by each other. Okay, so I'm going to do this again. One thing, so I'm just copying these lines. So it should keep asking. Now, one thing to note, everything in while loop, you notice when I copied and pasted? So I'm going to do that again. I was like, hey, let's just copy these lines and paste, right? Now, if these to be in the while loop, we need to have them indented. You hit the tab button and indent. One hint, I could just highlight both and just hit tab and go, boom. Now they're lined up. you got to make sure these are lined up to be in the while loop. And then after they do this, I'll go print your, okay, let's say your numbers x and y are evenly divisible. There. So watch this. Give me my first number. Let's say 7, 3. Hey, those aren't divisible by each other. So I try again. Go 9 and 2. Nope. But what if I go 10 and 2? Your numbers 10 and 2 are evenly divisible. Yay, I'm done. Great. So that's my code for that one. Hopefully you practiced yourself, or if you didn't, you can understand what I'm doing here. I get my 2 inputs. Now, one weird thing with my code, if my first number should be bigger than my second number. So let's say if I do 2 and then 10, it's going to say they're not divisible by each other. So, because it didn't really ask, it says if the first number is evenly divisible by the second. Oh, I want to say, they did say, hey, the first number is not evenly divisible by the second. So I might want to say, and put a prompt here, say, hey, print, give 2 numbers where the first is evenly divisible by the second. So you want to put some instructions of what people were supposed to do. So I should have done that at the start. And so then I can say 14 and 2, and those are evenly divisible. So put those directions if you're making a real code thing like this. I guess for this project, you didn't really have to. But I just want to show you with me doing that. I'm actually going to open this in Trinket so you can see the full thing. Great. I don't care if Python 3 is now available. So here's the full code. Print x and y. While loop right here. Form the user of the result. So watch, here's what I did. You want to play around with it, great. All right, folks. I am going to pause at this point because I did a lot, and we'll have a part 2.